Hello everybody, we'll begin now and continue as more people join us. Good morning to those who are joining us from across the Atlantic. Good afternoon to those joining us from Europe, and good evening for those joining us from Asia. We are delighted to be hosting today's webinar of Conquering Airtight Regulations with our World First Portascanner AIRTIGHT 520. I'm delighted to introduce myself. I'm Chloe Barker, Head of Global Distribution in the Chairman's Office at Coltraco Ultrasonics. And I'm joined by my colleagues Daniel Dobrowolski, a Senior Physicist, and my colleague Major Bernard Hornung, who is our in-house specialist, the Head of Operations for the Built Environment. And we will be exploring today to understand ultrasonic quantification of leaks, as well as applications within the built environment. So I'll begin. Firstly, this is myself. Should you wish to email me for a copy of the presentation, or it is being recorded, then please do. My contact details are on there, and I'd be more than happy to provide a copy following. I ask that if you have any questions, please do put them into the chat box. My colleague Angus is joining me here to my left-hand side, and he replying to questions through the chat box. But also at the end of the presentation, we will be having a question and answer session. So we'll have an opportunity to be able to speak with our experts to get to know some of those questions that you would like answered about our groundbreaking new technology. A little bit about Coltraco Ultrasonics. We are headquartered in London, and we operate across a diverse array of 25 market sectors. We are engaged in research, design, development, manufacture, integration and sustainment of high exporting advanced technology systems, products and services. And we are delighted today to be joined with our customers and distributors across the world. It's very exciting for us to have this webinar today and to have such a global mix of participants today. Our company, Coltraco Ultrasonics, comprises of four parts. Our company, Coltraco, our laboratory, which is where I am today, which is co-located with the Centre for Advanced Instrumentation at Durham University. Our research organisation, the Durham Institute of Research, Development and Invention, and our Centre for Underwater Acoustic Analysis. We have a unique research environment where we identify and nurture brilliant minds. And within DIRDI, our institute, we undertake fundamental research into physical laws of the universe, alongside research in physics, mathematics, engineering, computer science, acoustics, electromagnetism and information engineering. It's our research excellence that makes us the partner of choice for our customers and distributors in 120 countries. And we deliver genuine value to our customers through our scientific and institutional values and the quality of our commercial and technical services. So it's very exciting for us today to be able to present to you the Portascanner AIRTIGHT 520, which is a result of our research and our commitment for excellence. So moving on, I would like to pass on to my colleague, Daniel Dobrowolski, who will be leading us through to understand ultrasonic quantification of air leaks. So Daniel, do confirm that you have control of the presentation?
Thank you very much, Chloe. I think I do have control. So hello, everybody. My name's Daniel Dobrowolski. I'm a senior physicist at Coltraco. I was also the lead developer of the Portascanner AIRTIGHT 520. There we go. So as a result of our history in watertight integrity monitoring for the Royal Navy, we have learned that it is one thing to be able to identify leaks, which is the ultrasonic equivalent of the smoke pencil, and quite another to quantify their accuracy and the size of the leak as to determine the ingress of water through it. Back in 2020, the Portascanner AIRTIGHT 520 was a spin-off technology of the Portascanner COVID-19, which we developed as part of an emergency response to the COVID pandemic. We were awarded a government grant from Innovate UK in order to reduce the infection spread in NHS hospitals. From that device, the Portascanner COVID-19, which was for negatively pressurized ICU wards, we then developed the Portascanner AIRTIGHT 520. While Coltraco has a 30-plus year history of producing reliable and accurate ultrasonic instrumentation, our latest technology in this space contains a number of substantial improvements that allow its capabilities to greatly exceed earlier generations of the Portascanner and other similar technologies. Firstly, the new generator produces a far more consistent signal temporally and spatially, meaning that the time averaged signal amplitude picked up by the receiver is a function of the leakage size. Without this stability of signal, any measured value would be affected more by fluctuations in the generated signal than by the size of a leak. This is an innovation both in terms of hardware and in terms of software. We have undertaken theoretical and empirical research, both in-house and independently through the National Physical Laboratory. That is the UK's foremost measurements and standards laboratory, into the effect of leak size and shape on ultrasound. Phenomena such as diffraction, reflection, and the geometric spreading of ultrasound all affect the received signal in a calculable but non-trivial way. After deriving and validating the relationship, we were able to program it into the instrument to quantify leak size. The nature of leakage paths is such that there will always be some variables that cannot be known, at least to the required accuracy. Nevertheless, the means to quantify individual leaks with a reliable figure, reflective of the physical extent of the leak, is a valuable metrological feature and unique to this device. It is only now that such a capability is possible ultrasonically and therefore without the need for pressurization. It has also been crucial to have an understanding of fluid dynamics in order to predict the flow of air under a variety of conditions. This is all included within the device software to produce an instrument that is the first of its kind, a 100% British handheld portable analytical instrument, designed to complement existing airtightness testing, such as the door fan test or the pulse test. So why is it that the Portascanner AIRTIGHT 520 is so advantageous? Unlike general pressure tests, it allows you to specifically locate individual leaks and scientifically assess their significance. It allows you to provide evidence of your maintenance program, to locate, quantify, and record leaks in the form of a PDF report or an Excel spreadsheet, which is automatically generated by the device. It allows you to complement existing technologies to improve the efficiency and quality of your airtight room maintenance. Crucially, it is a precise instrument, capable of determining leak cross-sectional area, airflow rate, and the air permeability of a room envelope. This allows personnel to obtain a quantitative assessment of airtightness, meaning the leaks that matter can be sealed effectively and efficiently. Here is a quick animation of how the Portascanner AIRTIGHT 520 detects a leak. On the left-hand side, we have the generator placed behind a structure. On the right-hand side, we have the receiver. The generator emits ultrasound towards the structure, and the receiver wand is scanned around the structure until it picks up a leak. When it does, the indicator shows up both visually and in an audible sense through the headphones. Those leaks can very easily and quickly be detected using the receiver unit and then marked on the touchscreen using the touchscreen interface. Once the leaks are detected, they are then measured, and the instrument automatically calculates the cross-sectional area of any leaks detected in square millimeters, as well as the air flow rate in cubic meters per hour. It also displays the total airflow rate of all of the leaks within a structure tested. And there is a nice visual photograph of the structure on the screen. This is displayed using a very easy to navigate touchscreen interface. Data is then saved to the device and can be exported via USB. Here is an example of a report that is generated by the unit. This was conducted at the ATMA test facility, and you can see that on the second page of the report, there is an overall figure for the air permeability in cubic meters per hour per square meter at a pressure differential at 50 pascals. There is also a value for the amount of air changes per hour that would be expected in the building given the leaks that have been detected. Then each subsequent page shows all of the areas that were assessed during the process. There is a photograph that is taken with the device with all of the leaks marked and numbered. These leaks are then listed in a table, and their cross-sectional areas and airflow rate are also all of the areas that are tested during the process. So this can include things like windows, doors, areas of wall, even areas of roof section. The Portascanner AIRTIGHT 520 is very useful for quantifying leaks in a number of settings. So it can either be done before a door test, a door fan test, or a pressurization test, or during it or afterwards. Before the door fan test, it can quantify leak sites without the need to pressurize the environment. It allows the identification and measurement of air leaks for precise, immediate, and often low-cost remedial action. It complements the pressurization test and gives contractors the ability to generate more competitive quotes for pressurization tests related services, and more information can be known about the enclosure before the test. This means that any leaks that are picked up can be very quickly sealed if they're easy to do so, so that time isn't wasted during the full test having to do this. And therefore, there is a much higher chance of passing the door fan test. After the door fan test, the Portascanner AIRTIGHT 520 can also be used for periodic maintenance of any room or enclosure. This is important because weather and environmental conditions can affect air tightness over time. I'm now going to show you a couple of case studies that were undertaken with the Portascanner AIRTIGHT 520. So in January 2022, I visited the ATMA testing facility, that's their building performance hub, where there was a full building within the facility which could be assessed in terms of the building fabric of that space. During that process, the Portascanner AIRTIGHT 520 was able to identify and quantify leaks that had been found with traditional basic methods of leak detection, such as thermal cameras, smoke pencils, and anemometers. But importantly, it found leaks that could not be found with any alternative method. Another case study was with a passive house build in December 2021. That a passive house build is, for those who don't know, a very, very high standard of air tightness, about 10 times higher than the general requirements in the UK. And that visit was conducted during a door fan test procedure. The door fan test found that the building only just passed the standard of being passive house, which was unexpected because they assumed that it would actually be a lot more airtight than it was. And the Portascanner AIRTIGHT 520, within a matter of a couple of hours, was able to assess a large region of the building fabric and actually identify leaks that had not been picked up by the smoke pencil. So the Portascanner AirTight 520, as demonstrated by these case studies, was able to transform leak detection in a way that meant it's very, very easy to detect leaks, but also in a very, very much more of a scientific way than the sort of the art that is using a smoke pencil, for example. Now, across the world and in different parts of a country, there are often very, very different regulations as to how airtight a building needs to be. So I won't dwell particularly on the UK regulations, although this slide details what they are. They're usually given in terms of air permeability. So that is the cubic meters of air that flows out of a building over a certain time period and over a certain area. So that's in cubic meters per hour per square meter. And they're usually specified for some pressure differential, in this case 50 pascals. So that's the difference in air pressure from the outside of a building to the inside. And different buildings within the UK have different specifications in terms of air tightness. But the AirTight 520 is a very useful device in order to quantify these and to complement the existing methods of doing so by actually, unlike the door fan test, being able to isolate those specific areas of concern. So thank you very much for listening to myself just then. I'm going to now pass over to Major Bernard Hornung, who will talk a little bit more about the built environment.
Good afternoon to all of you, and thank you very much indeed to Chloe and also to Daniel. I think it must be very rare to find oneself in a position where you have an idea and the person you're speaking to has all the resources and the finest minds in the country to develop it. And that was the position I found myself in when this awful pandemic broke out. And I was with Dr. Carl Hunter, the chairman of Coltraco Ultrasonics. And almost 2 years on, we're now in a situation where we have to accept that pandemics do not die, they fade away. And that is what we hope COVID-19 will do in 2022. And as this awful pandemic settles its fate as an endemic disease like flu or the common cold, we hope that our lives will become easier. But behind this prospect lie both a stunning success and a depressing failure. The success is that very large numbers of people have been vaccinated, and at each stage of infection, from mild symptoms to intensive care, new medicines can now greatly reduce the risk of hospitalization and death. It is easy to take that for granted, but the rapid creation and licensing of so many new vaccines and treatments for a new disease has been a scientific triumph for the whole world. The failure has been to recognize the importance of good ventilation in the fight against coronavirus. And whilst vaccines were crucial in the fight against COVID-19, a broader strategy that includes preventative measures, such as good ventilation in buildings, is important too. Society-wide improvements to ventilation to prevent the spread of COVID-19 could also end up stopping most other airborne ailments. And if this is taken seriously, buildings, in particular hospital buildings, will need to be frequently and regularly tested for air leaks, whether they're still occupied or whether you're lucky and they're vacant. And we have developed the technology for this. Healthy people, healthy buildings, and a healthy planet is what this technology exist to support. And I believe that we must develop within the construction industry a future-focused innovation strategy for low-impact buildings. But if we're to make the right decisions, we have to have the right information. And our decisions will be sharper if we have the information derived from the technology which is being developed by Coltraco. And a low-impact building is one that reduces the resources used both during the construction and the use of the building, and throughout the consequential effects of that building on its location and on broader aspects, such as transportation options and general impacts upon biosphere. And the residential and other buildings which we occupy, schools, universities, workplaces, hospitals, must provide a healthy and comfortable environment that supports the needs of the occupants and the owners. And some of you will know much more than I do about how important air tightness is within buildings. Some of you will be using this instrument to ensure that the buildings we occupy are safe and provide a safe environment. And whether that is to do with thermal comfort, acoustic insulation, insect or pest control, security, fire suppression, ventilation techniques, temperature differentials, or whether you're creating data centers and in the server room, you deliberately want to create a hypoxic environment to reduce the oxygen and to reduce fire risk. Whatever the applications, whatever building performance you're looking to achieve, a pretty common requirement across the built environment and across the world is to be able to test for air tightness. But not just when the building is finished, but to be able, because no pressurization is required, to test building components, to test doors, to test windows in the factory before they leave the factory, to test during the course of the building program, to test whilst you're assembling the building. And I believe that this unique, the world first from Coltraco, the Portascanner AIRTIGHT 520, which we were fortunate to be able to develop from the Portascanner COVID-19, will transform many people's lives. And you, the technicians, will be able to work faster, better, and cheaper than your competitors. Thank you. Right, I think, Chloe, probably questions now, isn't it?
Yes, that's right. Sorry, I was just lost. Wonderful. Thank you so much to Daniel and Bernard for such wonderful presentations. I know that we've had quite a number of questions that have come in on the chat setting, so I'll just read some out. If anyone else has any other questions, please type them into the chat or raise your hand on the Teams function, and we will answer them all for your questions. So I know Angus has been replying to them live, but I think that it might be worth reading out some for everybody's benefit. So for example, can the AirTight 520 be used as a replacement for the door fan test?
So would you like me to talk about Daniel?
Yeah, please.
Yeah. So, Karaoke, yes, it's a good question, and the answer is that sometimes the Portascanner 520 can be used to replace the door fan test, but sometimes regulations do specifically state that you have to conduct a door fan test. In these instances, typically, if we look at fire installations, it's new installations, the door fan test is mandated. You have to have evidence that you've had a door fan test and that you've passed the door fan test. So in that situation, the Portascanner AIRTIGHT 520 can't completely replace that test, but it can be used as a complementary tool at multiple stages in the process. So you can use that prior to the test being conducted, so that you can go into that test with confidence that you're going to pass. Often we've spoken to many partners in various industries, and it is not uncommon for buildings and structures to fail these tests first time around. And they're costly. You need third party teams to come in and conduct them. They cost a lot of money. They take a lot of time, and they're very intrusive. You have to pull the door off, replace it with the blower, as I'm sure you know. So in these instances, the value of the Portascanner AIRTIGHT 520 is preemptive. We can make sure that you pass that first time without having to get the guys to come in multiple times. And if you don't pass, you can use the Portascanner during the test to find those leaks and patch those leaks up on the fly as you go and take that remedial action where it's needed most and when it's needed most. And then there are a lot of instances, so specifically follow-up maintenance on these kinds of things where the door fan test is not mandated, it's a recommendation. Well, in these cases, the Portascanner AIRTIGHT 520 is, it will help you kind of go above and beyond the requirements and be absolutely confident in your airtight integrity on your room or your structure.
Bernard, is there anything you'd like to wish to add to that?
No, thank you for that. I think it's very important. This instrument is here to complement other technologies. And I'm extremely grateful for Paul Jennings and others who developed the door fan blower test. And certainly, I think if you want to achieve passive house standards and get the passive house certification, you must accept you will have to pass the door fan blower test or the pulse test. So I think these pressure tests are important, and it's important that they continue and they serve us well. What we can do, very importantly, is make sure that you pass first and every time. So if you're a contractor, if you're constructing a building, you've got to deliver a building, and you're under time pressure, the last thing you want to do is to have a fail. You want to be absolutely certain that when the time comes and the door fan pressure test or the pulse test is conducted, you always get a pass. And I think that that is the strength of our technology. It is to make sure that you really do deliver excellence. And that is what the Portascanner AIRTIGHT 520 will enable you to do. Deliver excellence. Thank you.
Thank you, Ben. And I think that would answer Jesus' question about getting equivalent N50 value for a whole commercial building. I think that would answer Jesus' question also. Adam Sims has a brilliant question. Do you have to pressurize or depressurize the building to conduct a test? Bernard, would you like to answer that?
I can take that if
yeah.
Yeah, if you'd like. So yeah, so the answer is no. The building does not have to be pressurized or depressurized. So the Portascanner AIRTIGHT 520, it's an ultrasonic instrument. That means that any air leakage spaces, regardless of whether or not there's actually air going in and out of them at that moment, will be shown by the ultrasound. That ultrasound will be able to get through regardless of whether there's any pressurization happening. And just to add a little bit to Jesus's question on the N50 value, I think that's referring to air changes per hour. So the unit does give a value for air changes per hour. But as Bernard says, I would always suggest complementing it with the door fan test procedure or perhaps the pulse test procedure, if that is possible. I know that in some circumstances, it might be very inconvenient and perhaps too invasive to do the door fan test, in which case our instrument can provide that value for you. But I would always recommend doing it as a complementary technology, largely because some buildings might be more difficult than others to assess all of the areas. Some areas might be a little bit difficult to reach with a wand, and in those circumstances I'd recommend using a whole sort of toolbox of all of the tools available. But the Portascanner AIRTIGHT 520 is, as we've said earlier, probably the best unit out there in terms of speed and reliability, but also crucially the fact that it's able to detect leaks without pressurization is quite a good bonus feature of it.
Just to quickly add to that, actually, I think this is, when you talk about conducting door fan tests as well, a kind of a real bonus that you get with the Portascanner AIRTIGHT 520 is that you don't have to even have completed a building or a structure to be able to test it for leaks. If you're in construction, you can build a wall and you can test that wall as you're constructing the building before you have the entire thing built. Whereas with the door fan test, of course, to pressurize the room or the building, you need to be finished. So you're kind of right at the end, and going back and making those remedial changes, if you require any, is going to be much more challenging than doing that right at the early stages as you're putting things together. And the fact that you don't need to pressurize to test with the Portascanner is a huge advantage in that instance, I think.
Thank you, Angus. Adam has asked, I think you said it gives predicted air tightness values. Is this for the whole envelope of the building or the room you are testing, or both? For example, if I'm testing a new build dwelling. Daniel?
Yes, so it's a good question. The answer is both. It depends on what you choose to export in terms of the data. So you can choose to specify, if you've just tested a room, you can choose to just export that room's worth of data, and the value will correspond to the air tightness, whether it be the air permeability or air changes per hour of that room. If you decide to export all of the data for an entire building, then it will give you a total value for that building.
Fabulous, thank you, Daniel. Mr. Yasser Ali has got his hand up. Mr. Ali, do you have a question you'd like to ask? That's not a problem. So thank you, everybody. Are there any further questions? What affects the accuracy of the AIRTIGHT 520?
Daniel, would you like to take?
Yeah, that's a very good question. The largest factor I would say would be human error. So we generally, within our tests, we found that if the unit is used appropriately with a trained member of personnel, there will always be some small aspect of human error involved. When you do the measurement, for example, you're holding a receiver wand. If you were to hold that wand, say 10 centimeters away from where the leak actually is and try to measure it, then you're not going to get a good assessment of how large that leak is. But if you hold it within a reasonable area of that leak, there will be some uncertainty in that value. And we say that that tends to be around 0.5 millimeter in terms of, if you imagine a circular leak, the diameter of that leak will only be off by 0.5 millimeter or even less, actually, in many circumstances. A few other things that can affect the uncertainty or the accuracy of the process is if you one thing that you need to input into the device is the thickness of the structure that you're measuring. So in order to calculate the airflow rate, you need to know the thickness of the structure, because if you're measuring a leak through 0.5 meter thick wall, then that's going to be a lot less than through a very, very thin wall. So there needs to be some idea of how thick that structure is, and that affects the airflow rate through it. Another thing is the pressurization that you put into the unit. So if you're interested, if the regulations stipulate 50 pascals, then that's fine. You can put in 50 pascals. If you're looking at a realistic interpretation of what how much airflow is going to go in and out throughout a normal day, that pressure is going to vary throughout the day, and therefore that can also affect the accuracy. But in terms of sticking to a regulated pressure, that shouldn't come into your values. So those are the key things that affect the accuracy of the measurement. But when the instrument is purchased, there will always be a calibration certificate, and that will show the accuracy of the unit under a number of tests. And we tend to say that it's pretty precise and much more precise than any other method of quantifying leaks.
Fabulous. Thank you. Daniel, I think that does link to the question that Tim has answered, where he's asked about a limit to the wall thickness or the wall construction that can be tested. So is there a limit?
So there's so in theory there's no realistic limit other than maybe 100 meters or something like that. But there's one thing that is a limiting factor is if there's an overly tortuous leakage path. So the unit operates based on having an ultrasonic generator on one side and an ultrasonic receiver on the other. You're not going to be able to detect a leak if that generator isn't positioned such that it is at the sort of inlet of that leak. So for example, some leaks, it may just be the case that in the inside of the fabric there's a leak here, but the leak is almost a tunnel going up, for example, to the roof, and then in that instance that generator would need to be placed towards the roof in order for the ultrasound to get through. So the only difficulty is if the leak path is overly complicated. In that case, it can be detected. It just depends on where you place the generator. But in the majority of situations, you will find that the leak path may move back and forth and may be unusual. But as long as the generator is placed facing the outside of the structure, then it will be detected and quantified to within an acceptable accuracy.
Fabulous. And I think in some ways, Daniel, that links to the question of Franz von Fustenberg asking, does the ultrasound pass through the leak spots simulate the air? So is the ultrasound simulating air through the leak sites?
It's not, I wouldn't say it's simulating air per se, but sound waves are effectively pressure waves of air. So what a sound wave is a mechanical vibration where you can visualize it as packets of air which are bumping into one another and then forcing that energy to propagate forwards. So it is it doesn't have the same sort of movement profile as if you were to force air through a leak via a blower door, but it is the same. It is the same medium that's traveling. It is the air itself that is traveling and carrying that wave. So where ultrasound moves, air will also move, even if it's not exactly in the same pattern of movement.
Fabulous. Excellent. A question from Adam, with regards to the pictures for the reports, how does this work? I like the example you showed, identifying the key leakage points.
So I'll quickly respond to this one. I've responded to Adam, but for the benefit of anybody else. The photograph in that report is a photograph that the user would take on the device through the camera on the back. There's an 8 megapixel camera on the back of the device. And as you go through the test procedure, you're guided to take a photograph. And then the next stage in the process is that you go around the structure with the receiver one, with the generator on the other side. You look for spikes in those readings, and wherever you detect a leak, you can just tap on that photograph, and that will place a cross in that location, so you can mark those locations yourself. And the device will remember that, it will store that information. So when you generate the report, it will show you exactly where those leaks that you found were.
Fabulous, thank you, Angus. And I think we'll have to wrap up for some final questions now. A final question is from Mr. Sims. Can this also be used in building acoustics testing?
Yes, the answer to that is absolutely yes. I suppose there would be some caveats to that in terms of whether you're interested in knowing kind of what frequencies of sound a building is more vulnerable to in terms of whether that sound can get in and out of the building. Different frequencies can propagate more easily or less easily, but generally speaking, outside of the differences in attenuation due to frequency, if a building is airtight completely, then it won't let in sound. So if it doesn't let in ultrasound, which is very high frequency sound, then it's very unlikely to let in any more lower frequency sound. So this is a very, very useful way of ensuring that a building has the right level of acoustic insulation as well, and it can quantify it in very much the same way.
Fabulous. And one final question, as we're running out of time now, but if we buy one, do we get training? And I know Angus has answered this within the chat box, but I'll read out his answer that yes, we do provide training. We have training videos online, and we also can provide training via video calls. So if you purchase a unit, you can expect our full support in your capability and understanding how to use the equipment. I think one more question has just come in whilst a couple of other questions have come in whilst I said that. In normal atmosphere, all other than O2, so oxygen, nitrogen, air gases, also there that we can verify what are the percentages?
So I think this is maybe potentially similar to Mohammed Sabrisi's question, which I did answer in the text box as well. But so I think the question here is whether this will work for other gases, and the answer is that yes, but perhaps the flow rates may differ for different gases other than air. But essentially, the way the Portascanner works is we physically measure the size of the leak and the extent of the leak, and we give that as an equivalent cross-sectional area. And then we use mathematical models to take that leak size and predict the flow rate, and we take into account information about the structure. And specifically the models that we use are relating to air. So there will be some fluid properties of other gases that may be slightly different, but I think broadly speaking, you will still have a size of leak and a flow rate of leak that would be representative of what you would get with any other gas. And again, there's a couple of other ones I think. On piping, I'm afraid, unless you can get the generator kind of on one open end of a pipe, so that it's firing the ultrasound into the pipe, you wouldn't be able to use it like that, because the generator has to go on the opposite side of the structure. To very quickly answer Fran's question, would it be possible to place the emitter inside of a large tank and have it send up sound waves to be picked up by the one on the outside? Yes, absolutely. That's how the technology works. So you would place the emitter in a room or in a tank, and you measure from the outside. Of course, it depends on. You need to be able to access the inside of the tank, of course, but I assume that you can do if you're asking that question. So yeah, as long as you can get the generator on one side and the receiver on the other, you can measure kind of really any structure. Fabulous,
wonderful. Well, I think that's all that we have time for in terms of questions. Thank you to everybody for being so engaged. We've got your contacts in the meeting chat as well, so we will follow up on each of your questions on email too. If you would like further information, such as the pricing, a copy of this recording, the presentation, or brochures, or just more information, please do email us. Our contact should be in the link that you've signed up to join this webinar, but we will write to you naturally after this presentation too. So I just want to thank you all on behalf of myself, Angus, Bernard and Daniel for joining us today. And I think Angus has just put our contact details in the chat box. So if you want to copy down the email address, then please do copy those down now. But we will write to you all anyway. So thank you all very much for joining. It's been an absolute pleasure to have you with us today. Thank you.
Thank you. Bye-bye.